October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. Now, although the Snowy Murray development was complete by 1969, where we left off after the previous episode, in parallel to these works were the final elements which would make up the remainder of the Snowy-Tumut development to its north. Water leaving the Tumut 2 underground power stations rejoins the Tumut River, flowing from this point towards the Murrumbidgee River, but downstream of Lake Berrinjuck, and therefore is largely unregulated once leaving these two power stations until it reaches the connection with the Murray River. In this sixth episode, we cover off the construction and commissioning of the remaining components of the Snowy-Tumut development and the Snowy scheme as a whole, until future modernisation works were implemented after 1973. Let's go now and see the timeline of these final events spanning between 1965 and 1973, with the Tumut 3 works taking the majority of these years to achieve its full nameplate capacity of 1,500 megawatts and cap out the overall generation capacity of the Snowy Hydro scheme at 3,740 megawatts. Reflecting back on the scheme up to this point, the Upper Tumut development is complete and in operation, alongside the full Snowy Murray development in the south. The last components envisioned from the plans handed to Hudson are for Blowering Dam, alongside storages between it and the outlet of Tumut 2 power station. The Tumut River continues unregulated below T2 power station, with much of the area still in use as farmland. These regions would be purchased by the authority from landowners due to Talbingo Dam, Jaunama Dam, and Blowering Dam flooding these valleys. Blowering Dam would begin construction in 1965 and be poised at the edge of the mountain range before the river hit the vast and flat Tumut plains. Like several dams of this size across the scheme, it comprises of rockfill and earthen core, due to this being the most economic method available. The early works around abutment preparation were married with the diversion tunnel and outlet tower, these later becoming the pressure tunnel to the power station and outlet works downstream of the dam wall. Construction of the dam and power station would occur across 5 years, and once completed in 1969, permit storage and controlled release of the flows from the Upper Tumut development, and enabling 80 megawatts of power generation as part of the process. It's worth looking briefly at the Blowering power station, which would be made up of two systems, an 80 megawatt turbine and generator, alongside an outlet valving arrangement to permit flows greater than typically discharged by the turbine to meet the needs of irrigators downstream. Reading through many former annual reports, it seemed sadly upon initial commissioning that the generator had some issues, with these being resolved over time, but likely making very good use of the outlet work structure adjacent to the turbine unit in order to meet demand. With plans for Blowering Dam ready, permitting its construction, attention turned to elements between it and Tumut 2 power station, from which initial scheme plans had allowed for several dams and several power stations between. This, however, would only net approximately 400 to 500 megawatts based on these early plans. The authority instead opted to alter these plans, and this resulted in a much greater generation capacity becoming possible by lowering the capacity factor of these facilities and combining them into a single power station, Tumut 3. Jaunama Dam would lie below Tumut 3 and create a pondage from which Tumut 3 would draw water from when operating in its secondary mode, as a pumped hydro. Construction of Jaunama began prior to Talbingo Dam and Tumut 3 shortly after Blowering Dam's construction began, due to top water levels of Blowering actually inundating the lower structure of Jaunama Dam, as can be seen here, prior to its spillway gates being installed later in 1972. The final piece of the scheme to be built were the elements which comprise Tumut 3, these being the Talbingo Dam, the largest within the Snowy scheme, its earthen spillway carved through the adjacent mountain range, the headrace channel also carved through the same mountain range, leading to pressure pipelines, which would fall some 160 metres vertically towards the Tumut 3 power station facility itself. This piece of the Snowy scheme would be the largest, with them essentially, not just figuratively, moving a mountain as part of its construction. Much of the material later being used in the construction of Talbingo Dam to improve efficiencies. The scale of Tumut 3's components is massive, like many before it within the scheme, but due to this complex being built at ground level, it provides a totally new visual to the size of the elements constructed. Workers look tiny within the pressure pipelines, and even a small double-decker bus comfortably sits within the same space. During my own visit through the scheme and national park, my car was dwarfed when parked beside one of the pipelines. Talbingo Dam would take 4 years to build and be ready by 1970, whilst the works at Tumut 3 power station continued. I still find the spillway fascinating, given as just a simple concrete crest without control gates. It's very simple in nature and function. The Tumut 3 power station and pumped hydro would be built over the final 6 years of the total 24 years of the Snowy scheme's construction, with the full 1500 megawatt capacity being available towards the end of 1973. 6 250 megawatt turbines and generators were installed, with 3 of these being configured with 99 cubic metre per second pumps to return flows to Talbingo from Jaunama Pondage during pumped hydro operations. When these pumps are not in use, control valves and isolation gates close, and vice versa when the facility is put into pumped hydro operation during low energy demand periods. And so we arrive at September 1973, and Tumut 3 and its appurtenances are now completed and commissioned. We've reached the end of the works begun under William Hudson and his team on October 17, 1949, following initial blasts being fired. The full Snowy-Tumut and Snowy-Murray schemes together adding some 3,740 megawatts of energy into New South Wales, Victoria, and the Australian Capital Territory's electrical grids during peak energy demand periods. Although we've now reached late 1973, the journey of the Snowy scheme isn't quite over. It will continue in this form, however, for many years into the future, producing reliable, renewable energy for the Australian public and its industries, along with increasing agricultural yields throughout inland Victoria and New South Wales, through irrigation regulation and flow diversions. It would do so without major change until the mid-2000s, where some smaller additional components would be added. These, however, only adding minor energy contributions compared to the 1973 capacity, mainly looking to get the most out of wasted energy already present within the scheme. In the next episode, I'll also touch on some new works underway as I make these episodes, i.e. Snowy 2.0, the new link between Tantangra and Talbingo reservoirs, which I'll cover in further detail, along with going further into the past, prior to 1949, with providing some appreciation of the thought that went into the scheme prior to the plans being handed to Hudson. I'll look to touch on some of the scheme components shown on old planning maps which also didn't make the cut, and others shown on their maps which appear to have been given a new life, i.e. Snowy 2.0. Thanks again for watching, and look out for the next episode in this series celebrating the Snowy scheme and its 75th anniversary.